I'm Brian Fuller, whose title is not correct. It's a little out of date. I used to be editor-in-chief, went away for a couple of years, came back. I'm now editorial director for our EE Life community. And here for the fireside chat is Amir Aghdeh, the president of Tektronix. And we're going to talk for the next 30 minutes or so just about the challenges that face designers in an era of get it there faster, get it there cheaper, and get it there more compact. This comes at an auspicious time for tech because tomorrow, February 2nd, Tektronix celebrates its 65th birthday.
Yes.
As a company.
Yeah, that's very true. February 2nd, we've been, you look at the heritage of Tektronix now at the 65th year anniversary. It's just the timing of this couldn't have been better. It's 15 year for DesignCon, if I'm not mistaken, this year, and the 65 year of Tektronix being part of this community and part of the design community. So thanks for having us here. So
you have a big museum up at Tech, and it's too bad you couldn't have brought it down sort of as a portable thing, because I know a lot of the audience here would just sort of love to see the evolution of hardware going back years. But if you're ever up in the Portland area, you know where to go for that.
Absolutely. We have what we call a heritage center. We have been able to collect products over years from earliest stages, and we're able to show that. And most recently, the public broadcasting also did a piece on Tektronix specifically and the Oregon area, just displaying the heritage of Tektronix, where we have come from, and the companies that have been created, and a concept called Silicon Forest, just giving it a little bit more of a depth on what Tektronix has accomplished and what has brought to the area. Intel as well has been featured in that broadcast.
We want to talk about the challenges that face designers, and you have a unique perspective, having been in the test and measurement industry all of your career. You've done stints at Fluke and Credence, in Agilent, and in all sorts of areas. And you've been president now of Tech for 2 years.
Yes.
And so you've had a chance to see the challenges in this industry as they have evolved, unlike a CEO who might have come from a semiconductor company or a software company to run a test and measurement company. So let's talk about some of the challenges out there. We're all wirelessly connected, and that continues unabated. We're now in the 4G stage. Bandwidth is enormous. We have energy pressures that are facing electronics designers, and then the ever-present time to market. And you guys have an interesting sort of spin on how you phrase that, time to answer.
Yes.
I think, which I like. But let's talk first about wireless connectivity and how that's stressing design engineers.
Yeah, very good, Brian. As you highlighted, when we look at the macro trends that is taking shape and impacting the life of design engineers, we focus on those 4 key areas, and we look at each one of them and try to understand exactly how does a design engineer do the job that they're doing today compared to what they used to do and what they need to do moving forward. And the wireless area, just taking that as an example, you look at the number of devices that all of us are using in ongoing basis, the quality and how quickly we get new devices coming in. So on the individual level, that has tremendous amount of opportunities, at the same time pressure on the design engineers. But the other part of that is connectivity between devices to each other. The volume of data that is being transferred, as well as being able to analyze it and make decision on it. So look at traditionally a design engineer normally looked at the digital design area. You use a power meter, a scope, and maybe a voltmeter, and that's all you needed to do your job. And you do discrete design, and then you had this RF magician sitting behind the scene, and when you were done, you hand it to them, and they use their instrumentation, and they give you a go, no-go answers. You look at today, you have to be an expert in analog, digital, RF. You need to bring it all together. You need to understand the time domain, the frequency domain. You need to understand the modulation capabilities in order to use the spectrum efficiency. RF shielding is a key element of your design. And most of us, when we came out of school, we come from a different type of background. So now we're at the stage that we got to address all of these things, get products to market very quickly, and don't have a whole lot of time to go learn all of it either. So that's a challenge that we are dealing with.
And plus you have standards that are changing and popping up constantly you got to deal with.
Exactly. So, as a design engineers, again, we look at individuals that are using our product and we're working with them. We say, how many standards do you need to know? To begin with, you have the connectivity standards. So 4 or 5 of them. Then you have to understand the impact of it on display. Another couple on top of it. Then you have a storage that you got to deal with. A couple more in that area. And you got to bring it all together in order to design one product, one board to get it out. So you look at the complexity of what you need to do. It's just enormous. And that's what the design engineers are dealing with today in a day-to-day basis, and that's what we're hearing from them on an ongoing basis. Those are the challenges they're dealing with, trying to figure out how can we actually help them to make that a little bit easier moving forward.
So you got wireless connectivity, you got data bandwidth, which of course everybody wants more of. If we could be streaming this live with our iPhones,
exactly.
We would be. But we'd probably bring down this network, such as it is, in here. And so here's an unfair question. If you had to prioritize those two as an issue, a problem for designers, which would be the greater at this point?
Yeah, depending on what industries you're in, to a large degree in the computer semiconductor industry, because it's really hard now to differentiate of what you need to do, because devices are becoming kind of a full-purpose devices. But as a design engineer, the number one priority, I think, to understand the complexities of the bandwidth. You need to be able to understand it, to use it, to see what is taking place in the high-speed serials that you're using. If you don't know that, then it's really difficult to take the next step. So it is intertwined, interconnected, but I think if you have to make a call, I will make a call on looking at the high-speed serial, the bandwidth need to begin with, and then understanding how does that interact with various spectrum and the use of a spectrum that you gotta do.
Is there any more pressure on your industry today, given these two issues that we're talking about, to do a better job or a more comprehensive or just a bigger job on education? Because there's so much and it's changing so often.
Yeah, really good question, Brian. Recently I was in a university, the Dean of Engineering was asking me, he said, what kind of people do you actually hire? Or what kind of skills do we really need to teach them in order for them to become qualified engineers, next generation of people who are going to generate patent in this country? And we told them, in a high level, you need to understand miniaturization. You need to understand software. You need to become a really expert on analog, digital, RF. And you need to understand the importance of application. So think about it, we all went to school. How many of us took classes that taught all of that to us? Most of us basically, either if we were design engineers, we came from a computer semiconductor industry, the RF. Most of us came from the military government, aerospace defense area. And only in the last probably 4 or 5 years there has been a synergy between the two areas. So understanding what this evolution is taking place, understanding what the next 5 years is going to look like, it's a tremendous challenge. But one of the ways to deal with that is really mix it up a little bit. And what do I mean by that? There are a lot of people in this audience, as well as a variety of companies that are present in here, that have significant amount of patent and talent. The next generation of engineers that they're coming from colleges, I call them more of an iPad generation. Application focused, really cool with the software, try to mix that together. That's the blend that you want, and that's what the transition is going to look like moving forward. How do you get the traditional way of doing things and combine it with the new generation of the engineers are in order to create the next generation of innovation coming to the market, addressing the needs. We have seen that working, and we are kind of feeding the fire a little bit, trying to see if we can accelerate that moving forward by being engaged in universities. A lot of us are doing that, and helping new engineers really get that as part of their DNA moving forward.
So, two-part follow-up question there, and that is, are you getting what you need out of universities, particularly in North America? Because there have been enormous funding challenges in the last couple of years, and there were curriculum challenges even before that.
Right.
So, are you getting what you need? And then I have another question that piggybacks off that.
So these are, I mean, the way I look at them, it's you have to have a long-term horizon in here. If I show up in any one of the top-notch school, university, UC Davis, MIT, Georgia Tech, and so I want somebody that is really top-notch, you may get a couple of people, and you spend a lot of time developing it. You got to look at it as, I have an ongoing relationship with the specific universities. I get to know them, I know what the programs are, I fund some of the activities that professors are working on in order to really cultivate that and develop it over time. And then you start selecting all of that universities and helping them to develop it. The other thing that we have found very useful, and again, I know we don't want to talk about Tektronix, but these are some of the examples, and I've seen it in other places as well. Internship is a really powerful thing. When I was going through grad school, I ended up spending some time in IBM as a co-op student. And that was really helpful, understanding the realities of the environment that you're dealing with, learning what you need to do, going back to school and honing your skills. By the time you come out, then you're ready for the workforce. So you're ready to hit the ground running. So in short, it's a long-term investment on both sides in order to be able to develop it. And the timing of this couldn't be better, because they are looking for that type of partnership. Universities are looking for local funding, local support, as well as the worldwide kind of a presence in there.
So, follow-up question, big question, are you guys hiring? Because I know there are probably a lot of people out in the audience or at DesignCon or interested in looking as the economy picks up.
I'm sure my colleagues in here wouldn't be happy if I try to do an ad in here, but just to give you a couple of pieces, we have done a series of acquisitions in the last probably about 5 of them in the last 15 months, and we just opened today a new site in the Bay Area in San Jose. We had consolidated 5 of our presence, both on the Tektronix as well as the Fluke network. We have brought it together. And our goal is to add about 50% capacity in there. And the reason for that, Brian, is this is the hotbed of talent. This is where majority of the new startup, the core technology is, and as much as we like to have people to move to Beaverton, Oregon, some of these people, they like the sun, they want to stay in here. So we are coming to talent, and we're looking for really top-notch design engineers, people that have energy around this industry, they want to solve problems, they want to be part of this for a long run, and that's what we're looking for. So short answer is we have and we continue to add resources to round up our skills and set ourselves up for a long run.
Sun is definitely very good, and I feel for the people who are not able to make it here because of weather around the country. So let's shift topics a little bit. Last week, President Obama gave the State of the Union address. One of the key messages there is a familiar one from him, and that is a key part of the future economy is green energy. It's energy issues. It's the grid. It's the smart home. It's all those things that we've been talking and writing about now for several years. They've elevated up into sort of the national consciousness and out of engineering. However, at the same time, we're still solving those problems. The problems aren't getting any easier. Perhaps they're getting more intractable. Right. Talk a little bit about how energy is challenging designers.
Yeah, just going back to what I said before, how many of us took course in engineering about efficient power use? None of us. I didn't take it, and I know a lot of other people, they don't know much about it. So think about it. Only 4 or 5 years ago, if you bought a device, how much the criteria and selection was on a battery length. Yeah, I used to carry about probably 3, sometimes 4 batteries on a long trip. Go in Asia or Europe, and every 2 hours you change one of them. You buy a Kindle now, if you don't use 3G, 30 days, you don't have to charge it again. You can use it for 30 days. The battery life, this is just one aspect, it has become a selection criteria of devices. Of any kind of gadget that you buy, one of the key pieces that you look at is how long this is going to last without me charging it again. So, as a design engineer, what do you have to do? ASIC, low power use. And again, go back and take a look. I was talking to a friend of mine recently. He said, how did you deal with the complexity of board? Some of the board that you look at, they are so dense and they generate so much heat. He said, it was no big deal. You had a lot of these state gates and you added another fan. How many fans can you add to these things moving forward? So the efficient design, power usage, the footprint is becoming more and more important. And the high concept of the smart grid and all of that is all good and fine, but what does that mean to me on a day-to-day basis? What do I need to do differently? And that's where the design engineers have a challenge in their hand, from development of a custom ASIC, the FPGAs, the efficient use of the space, real estate that they have given, and also how do you manage generation of heat and the power usage. We see, I think Jay talked about it this morning, we see a significant opportunity in that space. But it's uncharted territory. I think if we, that's something that really excites us, and we have a lot of ideas in how do you put it to use and how do you take it to the next level, is what we're going to be seeing taking place over the next 12 to 18 months.
So we've talked at a high level about these 3 technical challenges. Now there's also a market challenge,
right.
Profitability challenge, and that's time to market. You guys call it, you have sort of a different context. You call it time to answer. When I first heard that, I had one thought in my head. I have a different thought now, which is about trying to visualize very complex issues that you need to deal with quickly.
Yeah.
Talk a little bit about that.
And so, set the stage a little bit, again, you're a design engineer. What did you used to do? You look at the scope and you saw a trace and you visualized it, and that's all you needed. That told you, some very basic information. Take a look at the volume of data that you're capturing today. At the end of the day, your sensors and data analysis is going to feed you significant amount of information. So what you want to do, you want to be able to analyze it and make a decision on it. On a single discipline, I can manage that. I know how to do that. Now you add all the standards. Now you add RF, analog, digital on top of it. You put video on top of it, and now start capturing all this information and trying to make sense out of it. So the reality of what we are dealing with here is a volume of information coming at us, the type of work that we need to do, and the amount of time that we have. 3 to 5 year time cycle for a new product is a thing of the past. You're thinking 12 to 18 months, and you need to pack all of these things and you get it out as quickly as possible. So what do you need in here? It's a concept of a apps format. An apps that would tell you go, no go. You don't get it, it's a no-go, then you can dig deeper, analyze further, debug further. But at least you want to have a kind of a methodology in order to navigate you and move you through the process. Most of the design engineers have significant amount of knowledge. The issue is the time. How do you use that time effectively? And the idea here is that we will give you the tool, we'll give you the processes that you need, and this is an industry thing. You will see it in a variety of form or shape to help you to make decisions quickly, to help you to get to answers that you want. This concept has a kind of a life of its own as well. So we talk about education. If you have a question, who do you answer? Who do you call? Is there a call center? Is there a method to go on the web to get all that information? Is there a method for you to be able to get that 7x24? Are there blogs that you can follow? the user community that can give you the best possible answers from people who are doing the same thing as you are. The concept is not necessarily, oh, just put another button on the next generation of product. Look at it broadly to see how do we make engineers a lot more effective in what they do day to day. That's how we are framing that as more of a time to answer or getting products to market quickly or be a lot more efficient in what you're doing.
So going forward, and we're probably bumping up against our time thing, but I don't have a watch, so I'm just using my gut. Do you see any sort of major disruptive innovation in your industry to address a lot of these issues that we've talked about? Or will innovation just continue apace as it always has, and you'll scale the mountains as they appear before you? The complexity of what we are dealing with would bring innovation. You have no choice. The old way of solving things is not going to get you there. Look at the FPGAs as a very simple example. You really don't know what is taking place in there. You have no way of probing it. You have no way of looking at what is taking place. You basically, what do? You use simulation. You use software. You run it, and then you compare it against a set of a statistical analysis to tell you, hey, it's good or it's bad. So the traditional way of doing things is not going to get you there. So take that again, that custom ASIC. What do I need to do in a real estate that I have, inability to probe it? Would I be able to build some kind of capabilities inside the ASIC to give me information that I need to make decisions? These are ideas that have been talked about for a long period of time. The breakthrough would come in if you can solve it in a format that is sustainable, that you can repeat it. I think there are going to be significant innovation coming in this space, both from an industry macro trends perspective as well as problem solving perspective, while the pace of the growth is going to continue. Personally, and from a company perspective, we are really excited about what is ahead from what we are seeing. The energy that we are seeing from the design community, from the companies that they are continuously doing innovation. We want to be part of it. We want to solve some of those things. We want to help them to solve it moving forward. So just an observation, in the Valley, most of the presidents of technology companies are older than their companies, and you're sort of the anomaly in that you're younger than your company.
Brian, can I get you to give my wife a call? Just a little bit of a...
Absolutely.
No. Well, thank you for that comment. I'm not that young.
You're not that old either. Anyway, I want to thank you for spending time with us up here on the stage and coming to DesignCon. I know you appreciate the sun, but we appreciate your input, and we appreciate your perspective. And thanks again. Enjoy the rest of the show.
Thank you very much, Brian. Appreciate it. Thank you.